Remember, we're going around for editorial fees. So if you are not paid, and I say that from Tuesday, you'll be showing me your receipt. If you don't have your receipt, meet me, I'll give you your receipt before you pay. And from Tuesday, I'll be seeing your receipt either in your phone or you have it hard copy. I'll be seeing you there on Tuesday. And bear in mind that if you are not with your receipt on Tuesday, don't bother coming because we have exercised a lot of pressure, right? Try and pay off. If you have paid half, try and finish it off. This was a lot of
Well, let's be fast, please. About 2:30 we should be going on. What's the time? Yes. Reason is that yes, Master Toka is a family man. So yes. So he's not around today. And my own self, I have like a lot of weight to do. Yes, so we need to be fast. So let's start. 2:30 will go. In fact, let's say 3 will go. So please, if you don't have my number, 090-2000-7142, message me now. Please message me. Get to like join the groups. I believe the Good Samaritan will help me and repost it like in let's say 5 minutes time. So just click now, message me. You get up to the plan then. Or you can even tell your friends to send the PDF from Vector. So please, as the government is going around to pay for tutorials, give him your number so that you can add it to the group. So please check the question. Read question 1 there. Read question 1 of government. Guys, from the PDF, read question 1. And please have it in mind that every class we finish, we normally post video on it. No, I gave you that assignment. You should have done it. And you did not even watch the video on WhatsApp. But actually you did. You don't have to go back to that. I don't want to go back to that. That's what we are going to do is vectors from the beginning. So please, read the first question here. Okay, define vector. Okay, we said our first vector is vector. Okay. Sorry. Vector is a quantity or any quantity with magnitude and direction. So any quantity with magnitude and direction is known as. I noticed someone is missing. Rita is very shaming. I for say. But I hear voice from all around. Any quantity with magnitude and direction is known as vector. And please remember I told you that magnitude simply means values. You know, the number is a magnitude. So once you see that number, it's talking about magnitude. But once you see direction, it's maybe an arrow, or you see something like I. So the next question. Explain the principle of vector transformation. Please watch. Notice that as we are solving this question, what I mean directly is to teach you everything on vectors. So instead of telling you, yeah, define this one, you see that by the time we cut across, we begin as we solve the process, we will be seeing us applying the rules. So vector transmissibility states that if two vectors are of equal magnitude, transmissibility, vector transmissibility. Transmissibility. Yes. Just like you can program, there's something that also physics. You don't have to just write stuff. Yes. So it says that if two vectors are of equal magnitude but opposite direction, that each line of action can be transferred. Okay. Vector transmissibility says that if two vectors are of equal magnitude but different direction, or opposite direction, two vectors are of equal magnitude but opposite direction, that each line of action can be transferred. The two vectors are of equal magnitude but opposite direction, that each line of action can be transferred from one point to the other. He says that if two vectors are of equal magnitude but opposite direction, that this line of action can be transferred from one point to the other. Please pay attention, see what I mean. It is in this vector transmissibility that in your secondary school they told you something about head and tail, and then tail, those days in secondary school. You can see what I mean. If, for example, I have that there's a vector moving in this direction, let's say this way, and there's another vector moving this way. Let's say they say this is 2, and they say this is 2. For the fact that they want me to, this shows that they are the same, they are equal value, but they are moving in different direction. What vector transmissibility is saying is that you can carry any of this vector and place each tail on the head of the other. Notice this part is called the head, and this part is called the tail. So what vector transmissibility is saying that I can carry this vector now, you have seen it, and place here. I say it, that is just it. So that is it. So if I try that, now whenever I have to carry, let's say I have this, and I have this. Notice that this is tail and tail, is it not? Whenever I'm having tail and tail, it is going to mean that what I'm going to be having is what we call triangular law of vectors. Not gotten here, but just note it somewhere. But whenever I'm going to be carrying the tail to the head of another vector, what I'm going to be having is parallelogram law. So if, for example, I have something of this nature, then let's say I'm going to have something of this nature. Let's do this way, so that we don't get confused. I have this. Then notice something. Notice that before I go this resultant, once a shortcut to learning this head and tail, there's nothing there, they are the same thing, actually the same thing. But just that when you learn it, they may look like one big deal. So notice that once you are placing these vectors to the right hand side, it will always give you tail head. And once you are placing it on the left hand side, it will always give you tail and tail. Which is the reason why I said that by the time you remember that law of parallelogram, you said that if I have a side this side, you should have a parallel side this way. And if I have a side this side, I should have a side. You see that by the time you finish doing it, what you have this side is still the same thing with this. Let's check it out. Let's say this is parallel to this. And then I have this, there should be something parallel to this side. Now notice that by the time I say, okay, this is parallel to this, and this is parallel, you see that I've gotten that tail and tail. You see that too? So once you are placing your vector on the left hand side, what you always have is tail and tail. Tail. But once you are placing on the right hand side, what you always have is what? Tail. So they are the same thing. And remember the law of parallelogram. It says that this diagonal, looking at these two, this side and this side, so this side looks longer. Yes, the longer side can give you the resultant. So if you notice for that of tail, whenever it's from the left hand side, you can now see that the minute you have this tail, whatever thing you have That is by placing now the tail to the head. So I can now place my tail here. So the minute I join this, I have my resultant. So it's very simple. Very simple like that. So the key thing is something just knowing that left hand side is and then the next question. So that is what they call vector transmissibility. And notice that this vector transmissibility helps us in addition and subtraction of vectors. That's the use. And another name for addition of vectors is what we call the resultant of vectors. How have you been now? It's like today's your first day. You are just resuming. Have you been coming? They have not been seeing you. How is your dad? I want us to be fast. If you notice, I'm in a hurry because I don't want to teach later then before 2:30. Because I know that once I'm giving you the word, 2:30, you will go. But I give you the next question. Number 3, actually. Okay, it was just triangle law of vectors. I've already done that too. Shebi, you know, but now let me state it. Triangle law of vectors. Right? Yes, this is the illustration. This is the illustration of triangle of vectors. So tell, use triangle of vectors. I've not started stating you. And whenever you are drawing a vector from the left hand side, whenever you are drawing a vector from the left hand side, you are going to get triangle of vectors. While whenever you are drawing a vector from the right hand side, you are going to get a parallelogram law. Now, this triangle of vectors states that the three sides, it says that the three sides of a right angle triangle, the three sides of a right angle triangle can be used. The three sides of a right angle triangle can be used to illustrate vectors. Can be used to illustrate vectors. Where the hypotenuse, the three sides of the right angle triangle can be used to illustrate vectors. That is to show something that has magnitude and direction. Where the hypotenuse represents the resultant. Where the hypotenuse represents the resultant. Where the hypotenuse represents the resultant. And you know that this side is called the hypotenuse, is it not? Yes. So where the hypotenuse represents the resultant. Now if I know this, it simply means that if, for example, what they're asking me to do is now parallelogram law of vectors. I will not say that parallelogram law is simply, I think there's a question on that. Shemi? But let's go to that one. What's the question? What is parallelogram law, Shemi? Okay, first of all, parallelogram law is coined, parallelogram is coined from the word parallel. It's coined from the word parallel. So, yes, it's coined from the word parallel. So for a parallelogram, the sides parallel will always be equal. The sides parallel will always be equal. If I hear that there's a side to my parallelogram or anything vector that I'm doing and I have 4 here, it simply means that the side parallel to this is going to go. The sides parallel, I think it's best down. The sides parallel will always be equal. So if I have, for example, 3 here, it simply means that what I have here as well is what? 3. Full stop. So parallelogram law states that the longest line of its diagonal, parallelogram law states that the longest line of its diagonal can be used to get the resultant of vectors. The longest line of its diagonal can be used to get the resultant of vectors. Can be used to get the resultant of vectors. The longest line of this diagonal can be used to get the resultant of vectors. So please, when you are not writing to it, you can still now go ahead to further explain it that once it's parallelogram, it simply means drawing vectors from the right hand side. So notice if I'm to do parallelogram now, it simply means that what I'm applying is that head, there. Are you seeing it? That was the illustration. Yes. So you have questions, you ask me. Please, once you have questions, call me back. That's the essence of this class.
you should not be drawn that.
Like, it should not be drawn this yes. Okay. The reason why that is the case. Okay, the reason is that once is addition I'm doing. Once is addition I'm doing. Notice that the minute I create this into 2, what I have here is not what I have. Is it not good? Yes. So it simply means that if I'm having this rule, for the fact that it's not subtraction I'm doing, for the fact it's not subtraction I'm doing, I'm trying to cover a situation where we have each of these sides. Okay, or the best way to put it is that since parallelogram law is simply triangular law of vectors twice, so I'm trying to prove that triangular law of vectors is also contained here. Remember that triangular law is head to tail, should we? Now notice that at the end of that, now having this is head to tail, right? The other one is tail to tail, no? So notice I'm now having tail and tail this side. Is it not good? Yes. And if I change it again, I am now having somewhere here, head to head. So I think the best explanation for that, in as much as that's the rule, but the best explanation to that is to show that inside the parallelogram law, I also have a triangular law. So because if I choose not to obey this now, I'm going this way. I'm going this way. Notice that first of all, it's not equal. I see it. This side is going to be bigger than this side. Is it not true? And there is a law from parallelogram law which says that the 3 sides of the vector, that is triangular law, states that the 3 sides gives you vectors. Here the resultant is a calculation. So if I'm doing this, it's not equal. So the only way to do it is simply making sure that what I have for each side is equal. So I think the actual thing is for equilibrium to be established. In summary, it's for the sake of equilibrium and balance. That's the simple answer to that. And please, I want you to know this, that in as much as I'm answering this question, there are certain questions you've already been asked. Do you know why? This is a rule. It's just like when you go to mathematics, they tell you that the equation of a straight line is y equals to mx plus c. Is it not good? Yes. You don't come to ask, why is y vertical axis and why is x horizontal axis? So that is just what you need to understand here. But I try to explain it that way so that you just understand that and see the practical approach to it. Alright, let's go to the next one. Illustrate equilibrium of vectors. You can see when the 3 sides of a vector of a triangle, when we have 3 sides of a triangle equal, what do we call that type of triangle? Equilateral triangle, right? Now, please pay attention. Once a vector is represented with equilateral triangle 1, or once a vector is happening at the same time, if you don't call it the same time, you say it's concurrent. Because you hear a question saying that a vector is concurrent. Can you hear me? Yeah. Or you hear that it is happening at equilateral triangle 2, or here it's happening at the same point. If they don't use concurrent, they use at the same point or at the same time. Just so that that vector is talking about equilibrium vectors. And once we have equilibrium vectors, it simply means that what I'm going to have in this case, for example, so let's say this is vector A, vector B, and vector C. So you see this. So in this case, what you will now be doing is that there is no part that you consider to be the resultant. What you now do, please, if you are solving a question like this, a question of this case, what you now do is such that you have, you see that our principle of cosine rule, which is r squared equals a squared plus b squared minus 2ab plus 180 minus do you still remember this? And remember that this thing is also the same thing as saying r squared equals a squared plus b squared plus 2ab plus shall we? Now, once you hear it is concurrent, or you hear that the question says something that the vectors are in equilibrium. The vectors are in equilibrium. You notice how these points are making. Vectors are in equilibrium. They are concurrent, happening at the same time. Or here are the vectors found in an equilateral triangle. That means that what you are going to be representing in that case is equilibrium of vectors. So in that case, I will have a situation where first of all, A will be the resultant equals to everything here. I will also have a case where B will be the resultant equals to everything here. And I also have a case where C is the resultant equals to everything here. At the end of the day, we are done. Because notice that for you to have an equilibrium of vectors, this thing will be given. Hope I'm not too fast. Yes. So once you are done with this now, in this case, in this kind of question, what you are required to find is actually the angle, which is this, the theta. So by the time I find the angle for this, find the angle for this, find the angle for this, I've gotten it. But notice that when you sum up the angle, it will always be equal to 360. So you can simply also say that the equilibrium of vectors is such vector that gives you all the angles of the resultant to be equal to 360. Listen to what I'm saying. I said, for example, you know this is not a question. We are using this as an illustration. We said that in this kind of question, where you are given equilibrium of vectors, that in this kind of case, you will have a situation where you will make A the resultant. Because in this case, for example, if I give you all the three sides of the vector, in this kind of question, the three sides of the vector will be given. For equilibrium of vectors. Now, if I have these three sides given to me, what am I now finding? It's going to be the angle. Yes. So if I know that, you may see that in most of the cases, by the time you finish this and you find this theta, make it theta subject of formula here, make it theta subject of formula here, make it theta subject of formula here. By the time you sum up all the angles you've gotten here, here, and here, it will always equal to 360 degrees. Listen to me, I said, by the time you finish, I did not say for just this angle. I said by the time you finish getting this angle, and this angle, and this angle, by the time you plus it up, the 3 will always equal to 360. See, what you are thinking of is angles on in a triangle, see what? Which is when you're giving me 180, you ask.
I know you like it. I will be.
Like I should prove it. We will solve your question on it. There's a question on this that we will solve. We will prove it. There's something that if I'm solving, see, if I'm solving anything that involves each of these angles, we always fall in the range of from 0 to 180. The same thing for this one. The same thing for this one. Naturally, there's no time when you finish solving something and you start adding up each of these angles. But what we are saying is that by the time you finish getting this angle, getting this angle, getting this angle, by the time you sum it up, everything should be equal to 360 degrees. Just note it somewhere as you are still having doubts. When we now solve question on it, look there, you see questions of equilibrium of vectors. When we now solve the question, if we check the angles, all the three angles, if we sum it up, we see if it will equal to 360. So then we prove it. Okay. Ask. See first of all. Every angle here is what? All the angles here is what? All the angles here is what? 180. Yes. So by the time you get, what we are saying is that we don't know, see now, if we know that there's an angle here, there's an angle here, we don't know this angle. Do you know this angle? By the time we do this, we know that there's an angle that is here, but we don't actually know this. We don't know this. There's an angle here, we don't know it. We are saying that if we get this angle, no problem, get this angle, no problem, get this angle, no problem. It's not really the question. The question is to get each of these angles. But we are saying that there's an extra knowledge to it that each time you finish solving these three angles, that by the time you add it up, it always gives us 360. See, let's calm down. Let's take it that equilibrium of vectors is a vector with that is concurrent and happens at the same position. Let's take it. Now when we solve question, we'll prove it.
Can you give us the division of the equilibrium of vectors?
Please, when I say, do you know what you do for me? Let's check down if there's anywhere we see equilibrium of vectors and see if we can do that question. Let's check. If your first question is not valid, so we say that there are vectors at equilateral triangle. Vectors found on an equilateral triangle is known as equilibrium of vectors. 17 into there. And 20. But see, shall we see that because of numbers tell you wisdom? In the never you wisdom, they will tell you if vectors acting on an equilateral triangle, there are some, or they tell you if the vector is concurrent, the vectors are concurrent, or they are happening at the same time. Now they say we should have this, and they are acting at what? Okay, now what are they asking us to find them? Okay, so let's say I have my general root, R square equals to A square plus B square, let me use plus 2AB plus theta. Yes. Okay. Now let's say in this case, in the first case, let me make 17 resultant. Remember the rule I gave you was simple vectors. You are making each of them the resultant to find the angle. So I have 17 equals 17 square equals to 18 square plus 20 square plus theta degrees. So do for me 17 square, what do you have? 289 equals 18 square 354. What 20 no? I have here 2 times 18 times 20. 720 should be then plus theta. Hope you know why I'm putting this in, so you don't have add it up. 324 plus 400, what do you have? 724 equals to 289. Then plus 720 plus. I can easily select this cross equality sign. So that I have 289 minus 724 equals to 720 cos theta. Okay, my point for you, what do you have? Minus equals to 720 cos theta. Can I say the number side? Is it true? 720. So I'm now having cos theta equals to what? Do for me. Minus 435 divided by 17. What do you have? Like this equals to cos theta. So if I make theta started on the formula, if I all normal theta, it will not become cos inverse shading. Now minus 0.6042. I appear for 127.8 or 17.17. That means 127.2 approximately 127.2. Okay, well let's go to the next one. If you like, remember what I'm doing here. If you like, don't remember it. I said once it's able to become a vector, or they tell you concurrent, or they tell you happening at the same time, or they tell you there's a vector at the lateral triangle, that you should make sure that in that case you are making each of the given values your resultant. Then using your cosine rule is very important. In fact, once you don't know the angle, you always use this cosine rule. In fact, if you talk about Pythagoras that you know, it's also from cosine rule. Hope you know. Yeah. Alright, let's go. Now let's do when. Okay, it's giving you a different answer. The one is giving you 1 4. You need to check it again. Are you sure this is calculator?
Yes.
We don't have time. Should we don't have time? Yeah, now see, let's do when 18 is the resultant. I will have 18 squared equals to 7. Equals to 17 squared plus 20 20 square. Should be checking for me so that I don't make mistake with the values. Then I have 17 plus theta. Should be? But if I 18 square, what do you have? 24. Equals here. 289 plus 10 plus 280. 680 equals theta. Oh yeah. That means that I will have 400 plus 680 plus 680 plus theta. Should be? It was 3, 2, 4. You notice that, okay, I can now do the same thing I did here, which is, so this is going to be 3, 2, 4 minus 689 equals 680 plus theta. If I watch for what here, I can divide both sides by 6. Okay, compare for me. So, in my next consider of my hand, consider equals to cos inverse. Okay, now this cos inverse means 1 over cos. Yes, 1 minus 0.5368. Well, therefore, we will be 122.4. Like this? Okay, increase.
40, so it's not 460. But
470. No problem. I can do it this side. Can I can't use this side, but let me write down all the figures I have. 127.17. Then I have the second theta to be 122.47. Should we? Okay. But write fast, so okay. Can I clean the top part? Yes. There's 6 following it, so check good. Please, class, is this what we got? Do fast. And please always take time to watch video we post after each class. So that when you are doing the assignment at home, you will now see that as you are reading through and doing the assignment, everything will now be corresponding well. Because once we post that video in your mind, me, I understood it in class. Let me save my data. Please, even if you understand here in class, when you get to still watch that video so you will refresh. Class. Don't worry, let me finish. When we finish, everything like maybe that you're imagining, I already know. So just get it. In as much as I might not get all your imagination, but you see that I will always try. So let me play this part. Okay. He said, did you get 360? Okay, got 360. When we get there, we'll not get it wide. Don't worry. So then see, the next one is when I'm making this one 20, this subject the resultant. So square equals to 17 square plus 18 square minus, sorry, plus 2 times 17 times 20. Okay? 18, yes. Then cos theta. Somebody wants to use 180 minus theta. Always change this to plus when you want to use cos theta. It's not hard. They are the same thing. That's cos 180 minus theta and cos theta. They are the same thing. Once you don't know the angle, just use cos theta, not 180 minus theta. We will still put God to sleep. We're getting to that point. Now, this is 400 shilling. Now, what we have here? 280 plus 324 plus 142 6 2 plus theta, right? Okay. Now 287 plus 324, yeah? 61 plus 612 plus 2. Then equals to 400. Shall so if this cross equality sign and now this is 400 minus 613 equals to 612 cos theta. Now, if I know this 400 minus 613 minus 213 equals to 612 cos theta. So now, if I do this 612 divided by 612, yeah, for me, what do we have? 0.348. Equals to cos theta. So if I make theta solid of cos crossing of theta will now be equals to cos of minus 0.348 shall be. But yeah, for me, what do we have? 0.365. See, once you want, if you want to approximate, because you have that 6 and 5, assuming it's less than, okay, no. So I have this degrees. The next thing that is what? Okay, now let's see the reason why it's so. Can anything this side? Now see, let's say that this is my equilateral triangle. I remember that all the sides of this equilateral triangle are equal. Is it not true? Yeah. If all the sides of this equilateral triangle, that is, if I have them, let's say whatever it is going to be equal to this side, it's going to be equal to this side. Which means that is the reason why they say that it is happening at the same time. That is one. It is happening at the same time, remember. One. Now remember I told you that once it's equilibrium, once they say that something is at equilibrium, once they say something is at equilibrium, you will not notice that even its velocity, just like when we did circular motion, we told you that the velocity of a circular motion will this acceleration, sorry, yes, I think that the velocity is constant, is uniform. While this acceleration points you towards the center. You still remember? Yes. So once we are talking about equilibrium, it simply means that it is a vector that is a circular motion. Its movement is a circular motion. That is, in as much as you are not seeing it, but notice that if it goes this way, it will come this way, meet the same thing. Come this way, meet the same thing. So that is why if you go to your textbook, some of the illustration, they normally put this as this way, and this way. That is trying to show you that it is acting at a point. So if in fact you are looking at it as a triangle, you are looking at it as a triangle, but the physicist is viewing it in practical form. What happens? So when that vector moves, its movement is continuous. Remember that what we are talking about in vector is something that can, velocity is a vector. So it's something that if in fact, even as it gets to this point, instead of stopping or changing, it continues. It still continues. It still continues. So for that reason, we simply take it that once it's equilibrium vector, it's vector acting at 360. So that is the point to note. So that is why we say that if you find all the points, this thing you're doing here is not necessary, but it's important to know that that is what equilibrium vector is all about. Vectors acting at 360, or is it vectors acting at a point, or is it combined vector, or vector acting at the same time, or vectors acting at equilibrium triangle. Alright, so let's go to the next one. Let's be fast. Let's be fast. Read the next question. Can I connect? Read the next question. From the diagram, find the vector magnitude. That means there's a diagram. Let me see. Okay. I have something like this. And I have Please, is it 3 you are seeing there? 5. Okay, this is the number. Okay, then I think another one, so we're getting something like this. Okay, now please, we're going to solve this thing, but now I want you to know something as we are here now. Let's know something about vectors so that as you are learning, in your mind, you already know how to construct what you are learning under vectors. Anytime you hear someone talk about vector, first thing is that that person is really expecting you to know that vector is talking about direction. So you know, which can be maybe pointing this way, all those are not east, south. That is the first thing. Another thing you need to know from this direction is that if, for example, I know that everything here is north, everything here is east, everything here is west, and everything here is south. If I hear north of east simply means at east, the northern part of east. If I hear west of south, it simply means that the person is in south. Now at south, the west of south. Are you understanding it? Yes. And another way to put that is, let's say here 20 degrees west of south. It simply means that this is south, 20 degrees west. I see it. So, and if I know this, what I want you to notice is the first thing about this vector direction. Then we move to all the things you're expecting on the vector. And if I know this, west of south, this is south now. Now this is the west. I think I just said southwest. Southwest simply means 45 degrees angle. Now starting from the south. If I hear northwest, just northwest, it means 45 degrees. But this time around, I'm starting from the north. So it's the same as saying making an angle with the vertical. But if I hear, for example, west-north or north of west, it simply means this is west, Chevy, but starting here. North of west is simply the same as saying I'm in west, the northern part of west. It's not the same thing with north of west. See, it's not the same as west of north. West of north means I'm in north, the western part of north. Are you seeing it? Why north of west simply means I'm in the west, the northern part of west. No, it's not the same thing. It's see, that's why I said I must talk about it. Because this is the part of the type that they normally bring up. If I say north of east, and in the east, the northern part of east. Are you seeing it? Well, if I say east of north, I'm in the north, the eastern part of north. Are you seeing it? so that confusion will not kill you that day. And the thing is that once you hear of this, when you're not drawing it, is this that I'm asking you that you are drawing? See, for example, whatever something you want it to represent between west, north, and south. But see, let's say you are talking about east. Now, if you say north, 15 degrees east, this thing is saying east of north. East of north. Now, when you are not writing it, you are not using that representation of I'm in the north. Then, and to this, then this. I see it. So, but this thing means eastern part of north. It's very important. So, when you see this thing in exam, you can also see it in exam where they come and tell you that something is happening at so part of. So you know how to put it. So now, another thing I want you to notice is how to get the angle. So once you see that north is coming first, you are able to interpret it and put whichever one that is coming first, then put its angle. The next thing is to know that that part that is coming first, that is the point you are moving the angle. That's the origin. So just like we said north of east now, I know that this is north. East of north, sorry, this is north. This is east. Is it not good? If it's written like this, it's simple. But the confusing part is when they come and say east of or this of. So if I know this, there is always 45 degrees in between 90. So since north is the part I am standing, I'm starting here to get that 50 degrees. Yes, no, like, yes, I'm using 45. Yes, this is 45 degrees. That means 50 degrees should be somewhere here now. Is it not good? Yes, but I always make that 45 to show the demarcation. Very important. So this is the first part of what I want you to note about vector direction. They always expect you to know this. The second part is what we call component vectors. If you don't call it component vectors, you call it resolution of vectors. And it simply means splitting of vectors into the x and y axis. So if I have a vector question, we have so many of it. But once that question is given, instead of expressing myself using cosine rule, any question you get using cosine rule, you can also get it using component vectors. And this component vector is actually easier. Because what you just need to do is to carry that vector, put it on the x-axis, put it on the y-axis, then use Pythagoras to solve the problem. So just be noting, as you start solving the question, I will not be telling you that this one is the one that is component. So another name for component vector is resolution of vectors. Now the third thing you will know under vector is what we call resultant vectors. And we know that resultant vector is simply addition of vectors. That is taking vectors from x and y axis to the hypotenuse, to the single vector. This effect is equal to the magnitude of x and y axis. I said taking vectors in x and y axis to a single vector. Taking vectors in x and y axis to a single vector, which is the hypotenuse, whose effect is the same as the vectors on the x and y axis. So if I know that 3 now, that is vector direction, that's the first one. Then second one, component vector, also known as resolution of vector. Then the third one is what? Resultant vectors. Is it not good? Then the fourth one is now what we call multiplication of vectors. It's now under this multiplication of vectors, you are now going to be doing the dot products and the cross products of vectors. Now, once you have done with this fourth, you now enter what we call moments of vectors. And that one is the topic for this one, which we've done moment last week, but I told you we are doing everything from the beginning. So how many? 5. Vector direction, component vectors, which is also known as resolution of vectors, resultant of vectors, shall we? Then multiplication of vectors, which includes dot and cross products, then moments of vectors. So once we know these 5 things, under anything vectors, you are good to go. Okay.
Where does the analysis now fall in?
Is it for which one? The vector analysis. Vector analysis is simply an introduction that is just talking about x and y axis. If you notice, everything we're doing here is talking about x, y, z. That is when it's in surface, it's just x and y. I see it. So it's more like still other resolution and resultant vectors, where you're talking about x and y axis. But this time around, you are now extending it to space, where you are not talking about ijk. Then you are not calculating the slope, the divergence, and the fall. All those things fall under x, y, z. Alright, so with that said, we can move to the question on the board. Is it not true? Yeah. So please, why I gave you that so that once you hear vector, you know where you are putting your mind. But you see, I have that first one on the board. What formula am I using for this one? Pythagoras, Sherry? What formula will I use for this one? Parallelogram is also cosine rule, yeah, or component vector method, which is resolution of vectors. So we'll do the two. We'll do this, then we'll do this one using the two methods. So let's do this first one. So I will simply say, since I have 6 here, and I have 5 here, this side is my x-axis, this side is my y-axis. So this is my resultant. And using that, it's simply going to be r squared equals to x squared plus y squared. And this is at 90 degrees. Is it not good? So for the sake of those people that are just coming, so 2xy cos 90. Cos 90 is what? Cos 90 is what? Let's check. If I have this here, do you remember that our principle? Call this 0, call this 30, call this 45, call this 60, call this 90. Is it not good? And I said when is sign look left, when is cos look right. So if I hold 90 now, if I look right, am I seeing anything? So I'm supposed to have cos 90 to be what? Thank you. So which means if I have this to be 0, 0 times everything here. 0 times everything here. You see that everything here will be 0. See that? So I'm left with just x squared plus y squared. So that is why I don't like this. I see it. That is the reason why for Pythagoras I don't have this. So Pythagoras is only used when it's at 90 degrees. That's why I have it. So let's put it down. I have my x going to be 5 squared plus y going to be 6 squared equals to r squared. So this is 25, should be? Plus 36 equals r squared. Then x ahead. Wow. So 25 plus 36 is what? 61? Wow. So take the square root, what do you have? 7.81. And they did not give us anything here. I think they told us that this thing is 5 Newton, 5 Newton, and resultant will be in Newton. But since they did not give us nothing for it, so it's just like that. And naturally, they will always give us. Oh, this one will not give us. Now let's solve the second question. The second question, once the angle, please write in your book notes. Once the angle is equal to 90 degrees, use Pythagoras. Once the angle is equal to 90 degrees, use Pythagoras. That is number one. Note one. If the angle is equal to 90 degrees, if the angle equals to 90 degrees, use Pythagoras method, which is this one. Acute angle is angle less than 90, shall we? And obtuse is angle greater than 90. So if the angle is less than 90, use cosine rule or resolution of vector method, cosine rule. And if the angle is more than 90, greater than 90 degrees, use this cosine rule, or which we also call parallelogram, the same thing. Or you use resolution of vector method. And anytime you use Pythagoras method, they ask you to find the direction. Always use that is tan theta equals to y over x. Where theta will now become equal to tan inverse of y over x. Once you want to use to find your resultant is Pythagoras method, Shelly. If they now ask you in that question, find the direction of the vector, find the direction of anything here. This is the formula you use, the power rule. But if you ever use this one to find your resultants, that is cosine rule, to find your resultant, simply use what we call the sine rule to find your direction. And this sine rule is given by, it's given by sine alpha all over the opposite lengths. All over the opposite lengths. See what I mean? Let's say I have something of this nature, and I have this. Let's say I have this part to be alpha. There will be an opposite length here. Let's say this is A. So this sine alpha, this angle that I don't know, all over A in this case, all over the opposite length A in this case. Now there will be an angle here. There's an angle here now. This angle I don't know. Let's say this is beta. All over the opposite length, which is, let's say this is B. So it equals to sine beta over B. Now let's say I have. But you notice that yes, this is just a case where it's true. I can have cases where maybe I have something of this nature projected, or maybe I have something projected. You will see different kind of question, and I believe it's that question. So if I have something of this nature, maybe I have this here joining it. So there's an angle here which I don't know as well. So if this becomes my gamma, this gamma now will be equal to this opposite length. So it equals to. So what it simply means is that the angle you are seeing all over the opposite length. So let's say this part now. Let's say this part is C. So all over C. We are just demonstrating. But when we start solving questions, it will make more sense. So let's now try to solve that one. I am happy also. I like it. You need to be very fast. We use Pythagoras once the angle given is equal to 90 degrees. If it's above 90 or less than 90, use cosine rule or resolution of vector method, which we also call component vector. I will teach you resolution of vectors now, and that's of cosine rule. We use tan theta. Anytime we use Pythagoras, use tan theta for your direction. While anytime you use any of these two, use sine. Yes. I want to play. Okay, now let's solve that second one. I will start with the cosine because we already know. I'll start with the component vector method, which is resolution of vector, because we already know cosine rule. So, components, once we hear anything component in physics, it's simply talking about x, y, or z axis. So I'll just say, let me be my x, and let this part be my y. Then what you will then do once is this pattern you are using. You will go to this and say, this thing here, in as much as it's at an angle, you see that good? Yes. It's at an angle, but notice that it's still standing up. So I will consider it to be on the vertical axis, but no longer going to be just saying 6, but rather it will now be carrying whatever is here. But this one is totally on the x axis. Yes, so I'll bring out all the things I have. So I'll come and bring out, I have 6, I have 5. Okay, now let's do this thing here. I have 120 degrees here, and we are still doing the polarization of everything. I have 120 degrees here. Okay. Now notice that if this is 120, I'm just putting this in to show you that yes, straight line can pass through anything. Is it not true? Yes, straight line can pass through anything. So if everything here is 120 degrees, if I choose to say, okay, let's use this now. This is the vector. This is this vector. Is it not true? Now let's say I choose to carry this particular thing now, this vector now, to the y-axis. What will be happening to this angle? So will it be closing? Yes. And what if I'm carrying it to the x-axis? What will be happening? It will be opening, right? So that means in that case, y is looking like it's going to be towards the angle, right? Yeah. But I don't want to use that approach. So before I do this, let's say I now try to balance this so that we now do that our angle rate will be horizontal. Let's do it. See, I have, then you don't get confused. I have this. Now, angles on a straight line, which means that everything here is going to be 180, should be? Yes. Which means that there's an angle inside here, which is 60 degrees. Do you agree? Yes. There's no confusion about that. Okay. Which means if this is 60 degrees, this particular part is also what? 120, right? Because you can see that if you project this thing now, this side is now looking like this side. So that means there's 120 here as well. Are you saying it? And this part now is going to be under 60 degrees. So you understand what I'm going to do now. So the one I always make use of is the one that makes contact with the horizontal. Because in component vectors, x is equals to cos theta and y is equals to sin theta. Not like if you use it other ways, it won't work. But we need to obey that rule so that we don't get confused about the line. So the one I'm going to be using for this now is going to be, if I'm using this now, I'm using it to be 60 that is here. So if I'm taking this now to x axis, you see that this angle will be close, actually. But if I'm opening it, it will be opening. So I'm going to be using that one. So I'll simply say that this is going to be 6 cos 60 degrees. And notice that cos, do you know that cos 6 and cos 180, they are the same thing, just that 180 will have negative. Hope you know. And that means that we need to check which quadrant is this 60 degrees. Which quadrant is this? First quadrant, Shemi? So if it's in the first quadrant, we don't have issue. Because in first quadrant, x and y is first quadrant plus. And how we get that plus is saying y is plus, here is minus x, here is minus 1. Okay? So if I know that, so I'll simply say 6 cos 60. Alright, now let's go again. For the y, automatically, if I'm taking this one now to y, it's going to be 6 sine. No, it's 60 we are using. We are not using 60. Don't confuse it. See, should we know that what we have is certain with what we have here? Is it not good? So we are trying to say, since we are not using this 60, that is here. We say we always use the one that makes contact with the resultant. If I'm carrying this vector, the solution of vector simply says, how do I carry the vector to the vertical side? And then how do I carry it to the horizontal side? So since this angle is what I'm using, how do I carry this now? If you come and stand, it's just like I have this now. How do I carry it to stand up? And how do I carry it to lie down? I want everything to be at y or x. There is no room for something like this. So if this is the angle I'm using now, no longer the 120, but I'm using this angle. It simply means when I'm taking it to x, I'm closing the angle. And towards the angle, we use cos. While away from the angle, we use sine ahead. So that is why I'm using the same angle. So if you start for you to remember this rule I gave you. Away from the angle, use sine. Towards the angle, use cos. Alright, now the next one. This 5 that I'm seeing here, this 5 here is only on the x-axis, is it not blue? It's not on the y-axis now. So I'll just write 5. Y on the y-axis, no 5, 0. Alright, it's at this point now you clear for me. You now plot for me. 6 plus 60 degrees. So you now add up. So it's more like saying summation of, you can use forces, so you say vectors on x and y axis. So summation on x, y axis. So do for me. Plus 5. 8. What do for me? 6 times 60. You still remember that our approach? 5 points. Please, need to calculate up. Wow. Don't wait for them. Okay, 5.20. I want to believe everybody's following. Hope we end before coming. Don't worry, we'll soon go. Please, always eat before coming to this place. It's very important. Let me tell you, see, do you know, sometimes they think the secret of first class is in reading. It's true. But if you don't have enough fuel, the reading will not go anywhere. You see that? Your GP tank needs to be loaded. Yes. So that you can be seen well. Yes. Some people, I know what I say, some people as I'm teaching, your head will do you one kind. Honestly, he not like this headache that does not naturally should not come, will just be coming. It's hunger. And if I say you've eaten something, it's because you did not eat something strong. So you don't eat maybe biscuits, bread, water, mineral, sugar, it's not food. You need to be eating something strong. Yes. I know what I'm saying, but the kids are always eating indomie. You eat something strong, not indomie. Somebody told me I'm very addicted to indomie. And we didn't have food in the house, I want to eat indomie. That's not the case. Alright, so please, now that we have this, now let's see. We've got to x and we've got to y axis. Now to get the resultant to simply become x squared equals to x squared plus y squared. Hope you remember this formula. So anytime we'll be able to get our vectors inside x and y axis, the next thing is to use the resolution of vectors to find our final answer. So now do for me 8 squared plus 5.20 squared. So 8 squared was 64. Yes. So 5.20 we don't need that. 0.04. Yes. Okay, add the 2 up. And 1.04, Sherry? Yes. You can see, I have r squared. Now let's take the square root of both sides. So r is equal to what? 9.54. Okay. Now please notice, and they not give us units. I believe they gave us units with maybe meter per second or whatever. Sure, I will do. That's why we are here. Don't panic. Alright, if we are not correct, it means the values you give me do not correspond. But we ought to be correct. Someone said that lie. You like proving. Alright, please, let's check. Let's check something. Let's not check the resolution of vector. But you know that the minute I use this thing, if they ask me to find the direction, what I will now use because I've used Pythagoras is going to be tan. Anything that involves you using Pythagoras to find the resultant, always use tan to find your direction. Okay. Now let's use cosine rule to see if we can get the same answer. Let's use cosine rule to see if we can get the same answer. What of a situation whereby they give us something that involves X, involves Y, and involves Z? Maybe there's a way they're going to, we'll see a question like that, and they give it to us. We can be able to do it, is it not? So we get there. That is using cosine rule. The situation where they give us X, something of X, Y, and Z, then the next step we should use cosine rule to find it. You know it's possible, right? So we get a question like that, we still try using this method and that method to solve it. So the key thing is you're learning this one. Can I claim? Well, I can claim this side. But there is no time for this. Even I know some persons have used cosine rule to get the answer already. So now let's go. I will say R squared is equals to A squared plus B squared. Let me start with this minus 2AB plus 180 minus theta. Should be enough. Now, when do I use this angle? When do I use this particular formula? You can note it. When the given angle is less than 90. Do you understand? Yes, because see, whenever the given angle is less than 90, by the time you come and do 180 minus that given angle, it will give you an angle that is greater than 90. And any angle greater than 90, the cos of it will always be negative. Are you saying it? So once acute angle is given, you can easily use this one. But when the angle given to you, when the angle given to you is exactly, how do I put it now? Yes. It's above 90. Shall we? I think that's the best way to put it. Sorry. When the angle given to you is less than 90, which is acute man, is it not true? Yes, because for example, if I have 30 here, 180 minus 30 is going to give me 150. Is it not true? And by the time I do it, I will have a negative answer. So once acute angle is given, angle less than 90, I use this angle. Now, when the angle given is above 90 degrees. Let's see. I will use this one. So let's check if we are going to be correct. R squared plus A squared plus B squared plus 2AB plus theta. Okay, let's check something again. Okay, if I put 120 here, something that is above 90, I'm going to have that. So this is also, that is why I said it's the same thing. Yes. So in this case, see, please, that's the noise. In this case, what it means is that, notice that we've gotten, when we subtract, we've gotten an angle that is above 90 degrees, you know. So I think the best way to put it, yes, we are thinking of it in terms of what we are to solve. But the best way to put it is that this particular equation is used when the angle given is greater than 90. Because let's say we did not put something to solve it, and we are giving something like 150 already. Is it not true? Because cos 150 now, when you get negative and get negative, it's going to be plus. Should we see it? Yes. So this one is best put when the angle is given is greater than 90 degrees. Because you see that even if you have 180 minus theta, at the end of the day, if you put an angle less than 90 here, by the time you subtract, the angle you already have that is given is not going to be more than 90. So this one is best. Somehow it's something that they are slightly different, close, but if you look, you now understand it. Because you see it, yes. So once the angle given is above 90, you can just go back and use this one. So you are not going to be doing minus theta again. If the angle given is above 90, no need doing minus theta. You just say, okay, this is not going to be, let's say, above, maybe they gave you 171, whatever. If you put it here, you see that it's settled with when this is less than. So it's somehow later. But this one is practically and exactly, once the angle is less than 90, just use this one. Because if, for example, I have 30 degrees here, any angle less than 60, the cost of it is going to be positive. You see how to do it? Now, so when I go and put it, solve, you see that that positive have achieved it. So that is why we say that this equation and this equation, they are the same thing. Just like you are now taking note of the angles. So if you are given an angle above 90 degrees, there will be no need to do 180 minus. Just go and put that angle, put minus here, you solve. Or if you are giving a small angle and you still insist on using this angle, just carry it and put here. And that is surprised to still have an angle that is above 90. I know if you want to understand, you will understand this. Shaggy, you will not. You don't understand it. Yes, once the angle is less than 90, in fact, see how you do it. If you are giving an angle, they tell you an object, a vector makes an angle of, let's say, 40 degrees, 50 degrees. You see that the angle is less than 90. This is the angle you are using. But if the angle you give it is above 90, this one is what you use. So what you are going to be looking at here is no longer going to be this 180 part, but the sign. So if you are giving an angle above 90, the sign will be negative in between here. You see it? Yes. But if you are giving an angle less than 90 and you still want to use this one, this is the one you remember. It simply means that you must subtract every small angle from 180. Every small angle that is below 90, you must subtract it from 180. But if you notice that you don't want to do subtraction, it's not hard. It's not hard. I know it's not hard. It's not hard. Alright, let's try to solve that question using our precise method. So since the angle I'm giving here, in fact, still what we'll do is so that you understand. Since we're cutting at this side, is 60, shall we? We will use the two angles and stuff, so this is the same thing. So now, I'm going to be having my R square is equal to my A square, which is 6 square, then plus 5 square minus 2 into 6 times 5, shall we? Because I'm using 5 here, I'll just use cos. The angle that is above 90 is 120 that is here, shall we? I just use cos 120 degrees because I'm using minus. But actually I want to obey that 180 minus 6. I will now say 180 minus this small angle because it's less than 90. Is it not 60 degrees? And by the time you need to see that you still have that 120. Every angle you have on earth has a corresponding angle. Just like you look at your protractor. When you see 90, you see 45. When you see 150, you see 30. When you see 120, you see 60. Shall we see? When you see 15, you see 110, thereabouts. So you see all those angles, they are showing you their correspondence. So I just do this.
Sometimes you do 180 minus 120.
No, it's not possible now.
For angles greater than.
Hey, where I can see it. You just spoke up. I said, if you are going to be using 180 minus theta, that means that the theta will always be for angle that is less than 90 degrees. But if you don't want to use it, that will can just say, okay, that is going to just be angle. So now look for me. This is 36, shall we? 25 minus. But do 6 times 5, that's 30, shall we? So minus 30 times 2. Follow me and be doing this, you know. So I will not finish here. He says I will make mistake somewhere. Please, square cos 120 degrees. Okay, this should be given. Okay, then times minus 60, shall we? Okay, then 25. Plus 36. But do for me. Minus 60 times minus 30. Plus 30. Should we? 25 plus 36. But the everything for 1 year. Minus 1. Take the square root of both sides. 1 year. 9.5. You see what we got for the other ones? Yes. That means we are correct. It's always the same thing. So how you do this thing is, once we are through with this class, I will still post the video. Notice we are recording the video. We normally record video for our class. So once we post it, go and watch it till you understand it. All these things you're going to be doing this semester, they are more hard. Yes. And the day we do our marathon class, we will now tell you the secrets and the reason why we'll be making sure that every Saturday class, this is the pattern we follow. This is the pattern we do this one. That's your good news, we need it. Yes. Alright, so please, I want you to now find me the direction. Using the principle, since what we did here is using cosine, Now you find me the direction using sine rule. Remember we said once we use cosine rule of parallelogram rule, now what we use to find the direction is sine rule, is it not true? Yes. So using sine rule now, find me the direction or find me the angle between them. When I mean angle, see the angle we are talking about in this case. If for example I have this, now let's say I have half here, find me this angle, or if I don't even point it here, since I know that this is 60, find me the angle here. In some questions, when they tell you find this angle between the direction, they can also be the second as saying the angle between the resultant and the vector. So the angle between this resultant, this is the resultant. Now this vector is 0. The angle between these two, that is what you are finding using that sine rule. Now this is this vector on the x-axis. The angle between these two. Notice that the angle between the two of them is what is 60 degrees. So the angle between the resultant and this vector, find it for me. Let's say this one. And then this is parallel to the shading, and this is parallel to the shading. So everything we are doing today is very simple. Have you not noticed? We are giving the answer. It's See, I will quickly jump to question 9. So once we are done with question 9, we go, because notice that question 8, component vector, is a solution vector now. We've done it. So let's quickly go to question 9. They say a vector A of magnitude 8 units points Q east, and another vector B of magnitude 12 units points in the direction of 70 east of north. Full stop. The angle of force is given as that. Connect. Be fast. This is the last one. Please have it in mind. That from Tuesday, once you hear it's time for tutorial, if you are part of the switch class, you move to agric faculty. If you are part of the general class, you stay in hobby or we come down to mass course. So we are dividing class now from next week. So all the switch class students, you move to agric. And anytime we are moving to agric together, that means all the switch class students will use the hall at the S3. Why general class will maintain the auditorium? So you know it. So that anytime you come to our building, you do not see us. Know that we are targeted during the week. And when we are targeted, if you are a switch class student, the 200 level class, that's where we will be using for switch class. Why the auditorium is for general class. So please, from next week, have it in mind. Tuesday, I notice that we normally have lectures on Tuesdays. A lot of lectures. So if you notice, once you notice that everybody's having practical lecture, we will not fix class on Tuesday. Like this past week, we did Wednesday, Thursday, and Friday. So that we can accommodate everybody. Then Saturday class is normal. 8 till 4 p.m. The only reason why I'm leaving this class by this time I'm leaving is because I want to pick wedding, and that wedding is a lot. And it's a lot of things you need. So if not, our class is solid. Saturday is from morning till 4. Some of you, even all this time you see many Emmanuel coming to teach, Daniela coming to teach and the rest. Mine are talking that you still look and handle class from 8 till 5 to 6 p.m. The same thing with myself, yes. When we start marathon class, that's why you normally tell you guys ask your seniors when we dismiss. When we start marathon class, it will always be from morning till evening. Morning till evening. Because that's how your lectures will drop. Yes. So please, let's solve that last one. I can do it now. Okay, but are you done with the direction? You've not found the direction, Shelly? It's part of your assignments now. Okay, should we do it? Yeah. But that means we'll do the direction. See what we'll do? We'll do the direction, then we'll go home. Yeah. From our next class, we'll not start where we stopped. Yeah. Okay. Let's do the So whenever you hear direction of vectors and vector use this parallelogram, or even whenever you hear direction for triangle and a vector. So for that reason, I will say sine alpha in this case. This angle here. Notice that the opposite length is this. Is it not true? Yes. So I will say sine alpha, all of the opposite length, which is what? 5. Okay, now let's say I have my beta now. Shall we? Sine beta. Sine beta all over 6, right? Okay. Now let's check something. Now there's an angle here, is it not true? What's the angle? 120 degrees. In fact, I want you to know that the angle that will always be facing your resultant will be the bigger angle. You can note it somewhere. Angle greater than 90 degrees is the angle that will always be facing this your resultant. It's important to notice it. So anytime you are using your cosine rule, you can obey those 2 rules. So if you want to make this easy for yourself, you can still remember this. So I will say that it is also equals to, now this angle is sine 120. Is it not good? All over. That is facing the resultant. What did we get for the resultant? 9.54. Alright. 9.54. Now what we now do is notice that in this case, I will now equal everything down to the extension I'm saying sine 120 degrees because I have everything here. All over 9.54 is equals to sine alpha all over 5. Finish. So by the time I get this one, I can now say I've gotten this one. Or I can also even say, if I really want to, I can also say sine 120 over 9.54 is equals to sine beta over 6. Can you see it? Yes. So whichever one you put is okay. So that is what that sine rule is all about. The angle all over the opposite length. Alright, let's solve for this. Let's first solve for this. So I will now say making sine alpha set of the form of cross multiply. So that I will now have sine alpha should be is equals to 5 sine 120 degrees all over 9.54. So that alpha now will be equals to sine this crossing what sense instead of saying divide. So sine inverse of 5 sine 120 degrees all over 9.54. Punch for me. Yeah. What do you have for everything? Or do for me 5 sine 120 is what? 0.8. So I have the same that says sine inverse of 0.5 sine 120 is what? Yeah, please, I want to be sure. 4.330. That is 5 sine 120 gave me 4.330. Okay, all over 9.54. Do 4.330 divided by 9.54. 0.4539. So remember that this is current sine inverse, shall we? And now, punch sine inverse of 0.4539. 26.99. So 26.99, which is approximately 27. So approximately 27.0 or 27. So now let's go. Now see, this is my alpha. Should you remember? No. So I can come and put that this is the setting I start saying that this is equals to 27. Or because I want to use degree of accuracy, let's just put it at 26.99. When you have just 2 decimal places, it's best to leave it at 2 decimal places than being it to whole number. Because the more decimal places you have, the more accurate you will be. Yes. Now let's go to the next one. That is for beta. Let's find for beta. That is the angle. That is the angle between the resultants and that x-axis. Can I tell you this one? So please, this semester we've been able to cover units and dimension, but we are going to read units and dimension because we did it last week, and the number of you are doing this week. Yes. So this semester we'll be able to cover vector analysis, and when I started, vector analysis is supposed to be chapter 9. Now we've entered vector, reduction to vector. So By Tuesday, our next class, we're supposed to complete everything vector so that we enter our third topic, because I said we will complete series and dimension. And our third topic is going to be moment of vectors, or you say moment of forces. So moments. So that's going to be our topic after vectors. I can claim.
Yes.
So it's going to now be sine. Let's say I now have sine. Do you know what I will do? I will do sine alpha. And sine alpha is 26.99, should be? All over. Each corresponding length is what? 5. I want us to be checking everything to be sure that we are correct. Shall we remember that physics is all about proving? So by the time we do sine 26.99 all over 5 equals to the one we don't know, which is sine beta, yes? Sine beta all over 6, shall we? See, as I'm doing this thing, I want somebody so that we'll be sure if we are correct, because we need physics is all about proving. Somebody should let me do that for us, maybe sine 120 for the two of them. Okay, I'm coming. So, first of all, should we go to the resultant to 9.54? And equals to, okay, sine beta, should we? Over what? Over 6. Yes. So, we need to check so that at the end of the day, we now know what we're saying, what we are releasing for whatever is not there and what it should be there. So, do this one. Why we do this one? So, you got the sentence? Okay, it's the sentence. Okay, so which means that whenever you rotate it, you are correct. Okay, so that's what the essence. Alright, now I have this is going to be 6 sine 26.99 all over 5 equals to sine beta. So that by the time you do beta, basically beta sort of formula, you now have sine inverse of 6 sine 26.99 all over 5. I punch everything for the word here. I punch everything. Do 6 sine 26.99 divided by 5. Then that is the sine inverse of everything. What here? 33.00. That is 33 now. Now, what this thing means is that I know that since this is an angle in the area, right? Yes. So please, we will stop here for today. But when we post the video, I want you to take it serious. Watch it, rewatch it, go through it, think about it. You know that sometimes when you are finished, you are postponing the video. Please make sure you do it today. So read it today, don't postpone it. Go through it. From our next class, we continue from there. And we must finish vectors. Now, by the time we finish vectors, we enter moments. So please, do this revision so that you will not be left behind. It's not when we are moving, you will say that you are lost. So please, with that said, somebody should pray for us, let us go. Please, if you've not paid us for tutorials, tell your parents to call me. Yes. And then if you don't want to have paid the school, your parents calling me. Do not update you, or give it your parents my number, they'll call me. And you notice that once you finish talking, they'll deliver it. Because some of the time they might not tell you, but in their mind, if I give this one money, you talk. Yes. So please, tell them, take this serious. If I'm telling you lab notes, please, lab notes is available. If extra has entered on Tuesday, you get everything. Please. And if you don't have supplements for Friday, Tuesday you can still come for it. And if I'm calling you for Friday, please, Tuesday come and meet me. The file is getting too much. It's getting too much. Tuesday come and meet me. Somebody should pray for us. Somebody should